Alright guys, in this video let's talk about partial fractions. Alright, partial fractions is not really an integration techniques. Alright, we don't integrate using partial fractions, but partial fractions is a step that can be considered as a preliminary steps before we conduct integrations. In other words, partial fractions is used to simplify the functions that involve division like this. So consider a function that consists of two functions. We have the first function over with the second functions, alright, where of course the second function should not be equal to 0. Then the rule of partial fractions are as follows. Okay, before we talking about rules of partial fraction, right, let us see what actually happen when we apply partial fraction. Alright, just look at this simple example. Let's say we have these functions 5x minus 4 over x squared minus x minus 2, right? So how you're going to do, right, or what you're going to do if I want you to integrate this function. Okay, to do it directly it will be troublesome because this is quite, how can I say this, compared to the properties of integration, it will be hard for us to integrate directly. So one way to do is to factorize it out. Right, we split it, make each of them smaller fractions so that it will become a lot more simpler and it will be easier for us to integrate later. Alright, so the idea of partial fractions, right, is to teach you on how to split these functions, this kind of functions like this. Alright, that is the idea of partial fractions. Then after you have split it like this, make it simple, the next thing to do is just to integrate it, because it becomes simple that we can integrate it using the properties of integration, right? So that is the idea of partial fraction. Now to conduct partial fraction, one important rule that it need to be in a proper fraction. It means that the function at the numerator shouldn't be bigger than the function at the denominator. Alright, meaning that polynomial functions, we have x squared, x to the power of third, x to the power of fourth, and now we have quadratic, cubic, quadric, and so on. If this if the denominator is in quadratic, which is x squared plus something something, this should be in linear. The polynomial should be linear. You cannot or at least the same. You cannot have x to the power of 3 at the numerator, because if that happens, it is called an improper fraction. Right? So that is the first rule of partial fraction. For it to be done, you'll need to make sure that it is proper. However, if it is improper, we'll need to make it proper first by conducting long division methods. Okay, I believe that you guys are already familiar with this. It's just that maybe you'll need to look on how to conduct this on polynomial, right? So when we conduct a long division method, right, they will make the improper fraction proper. Okay, so when it is proper, already in a proper fraction, alright, we can then conduct the partial fraction. I'm not going to really emphasize on all of these steps. Right, it's just that maybe in these books, in the subtopic that we covered now, alright, there are two polynomial type that being covered here, the formula. Okay, so in four situations. First, we have a linear factor. Secondly, we have quadratic factor. How do we write the partial fraction for for linear factor? If we met with linear factor, when I say linear factor, it means that the denominator is linear. There is no x to the power of 2 and above. There is just x, right? Ax plus b here. So if it is just a linear factor, then this is how you write it down. A over ax plus b. A here is just a constant. You don't really need to bother with that. It can be any value, any numbers, any alphabet, right? A over ax plus b. Okay. Then let's look at a quadratic first. Okay, quadratic factor. What happens if you have a quadratic polynomial as your denominator? Then the way to make a partial fraction will be like this. Okay, your denominator will be in a quadratic factor, of course, and your numerator should be formed in linear function. Right? Try to make sense of it. Because of this is quadratic, right? This can't be more than this, so it should be less. So it is linear. Ax plus b. This is the function of linear. Alright, that is if there's just linear and quadratic without exponent. Now let's look at if they have exponent, which is a power. Right, outside the bracket like this. Okay, so if you have a linear factor that is with to the power of n with exponent, right, the way to split and make a partial fraction is by doing it like this. We can have a plus b plus c. It depends. If let's say ax plus b to the power of 3, then we are going to start with ax plus b, a over ax plus b over ax plus b squared plus c over ax plus b to the power of 3. That is how you write the partial fraction. And the same goes for quadratic factor. Right? The number of partial fraction that need to be written it depends on the number of exponent. If it is 3, the number of exponent should be 3. Okay, so and this follows a x plus b, and for this one we can say that maybe cx plus d and then ex plus f, right? Because they should represent different alphabet. Okay, so now that is just on how to make it split. The idea on how to split it. If it is linear, this is how you do it. It is quadratic, that is how you do it. And the same goes for exponent. The next things, after we have sort this out, alright, we'll need to figure out what is the value of the numerator of each of this alphabet. Right, you're going to discuss that through exercise after this. Then after we have obtained this value, meaning that we have successfully conduct partial fraction, and you will be able to proceed then with integration. Let's take one example. Let's take a pick. For example, you have this one, maybe this one, right? So this is a proper function where you have linear and quadratic, right? And as you can see, the solution given here, okay, this the solution here, right, based on the notion that the first x here is a linear function that has exponent 2. So that's why, as you can see, they put a over x plus ab over x squared. Then this is being treated as just a linear function, so c over x plus 2, right? If let's say you feel like you're seeing this like a quadratic, so this is I see this more like quadratic. I don't want to think it as a linear function with exponent 2, then feel free to use this. Yeah, this one. You can put x squared directly and ax plus b at the numerator, and then proceed with the second one, plus c over x plus 2. Alright, it is still okay to do that. Okay, now for this person, they are assuming this is just a linear function with exponent 2. So that's why, as you can see here, instead of using quadratic, they solve it using this idea, right, where you have a over x and b over x squared, right? So now that after you have you have figured this out, the next thing to do is to try to get the value. So to get the value is not that hard. You just multiply all of them with this numerator to get this, denominator, sorry, to get this. And then you will need to play around with the value of x. First, try to see what value that you input will eliminate. We have 3 unknown variables here. Just try to figure out what value that you input, the x, that will eliminate 2 out of 3 unknown value. For this case, if you put x equal to 0, as you can see, c will be eliminated, right? And a also eliminated. Then you're able to figure out b. And the next step, just substitute b into this value and do all over again. Try to figure out for this one, you already have b. That you only need to figure out the other two, c and a. So try to figure out what is the value of x that will eliminate one of the two. So for this one, put a negative 2. We later eliminate a, so you'll get c. And after that, just input everything to get a. Now that you have all of the value, input it back, right? Remember, this is the function, that this is the partial fraction of this function. Now that you have all of this fraction have been split, you can you can integrate them individually and to get this as the final answer. So basically, partial fraction is just for you to make it simple, right? And this is for long division where you have improper fraction. I think maybe I'm going to discuss about this in the next video together with some exercise, right? So thank you.